Hello, my name is Calvin Sao from Team 8 Screws Loose. This is a deliverable for two of the robots in our proposed search and rescue swarm. The problem statement is that following a severe earthquake, injured survivors will need a search and rescue team to locate them and perform first aid, as well as provide transportation if needed. The four robots that make up the swarm are the Combot, Search Bot, Obstacle Clearing Bot, and Rescue Bot. This presentation will focus on both the Search Bot and Obstacle Clearing Bot, or OC Bot. The search bot's main purpose is to fly over the earthquake area, locate survivors, and send the coordinates to the combot. The OC bot's main purpose is to locate the survivor and clear any debris to create a safe path for the rescue bot or survivor. The design of the search bot is very similar to that of a common drone. The main differences are that the search bot will have a thermal camera to locate survivors, as well as various sensors to allow it to fly autonomously. It is 275 by 290 millimeters in size and flies using four propellers. It has a thermal sensor on its underbody, distance sensors under each arm, and an antenna to send and receive signals. The SearchBot is powered by battery and functions using an Arduino chip. Its joints swivel by servo motors and its propellers are spun by gear motors. The design of the OC bot is very similar to that of a debris-clearing military tank. It is 35 by 12 feet in size and moves on a set of 8-wheel tank tread. It features steel ram plates and grab arms, as well as an antenna to send and receive information on the top of the grab arm. The OC bot runs on diesel. Its functions are powered by an Arduino chip and its movement by a large gear motor. The grabber arm opens and closes by dual servo motors. The Arduino code for the search bot will follow this activity diagram. It will be further explained in the next slide. When the mission begins, the search bot will fly over the predetermined area in a grid. Once it locates a survivor, it will pin his or her location and send the coordinates to the combot. It will continue to fly over one grid until it can no longer find survivors and then move on to the next grid. Once no more survivors can be located over the entire area, it will send a signal to the combot and return to base. The Arduino code for the OC bot will follow this activity diagram. If a survivor's coordinates are received from the combot, the OC bot will move to the location. Depending on the size of the debris, the OC bot will either use its arm to move debris and then plow through, or simply plow through the lower debris. The OC bot will reach its destination and alert the combot if the survivor was found or not. It will then enter standby mode. If the mission complete signal has not been given to the OC bot, it will repeat the process. However, if the mission completion has been received, the OC bot will return to base. The search bot cost is similar to a drone's with the exception of extra costs from various chips that make it autonomous. The more expensive parts are the four brushless motors to ensure longevity and precise flight, as well as a thermal sensor to locate survivors. In total, the cost comes out to a little over $1,000. Much of the bulk of the cost of the OC bot comes from its body, tread, and wheels. The cost is justified as the strength of the OC bot needs to be high in order to move any heavy debris and withstand any damage. Other parts like the Arduino and various sensors make the total about $3,000.